Okay, this is kind of where we left off. We were using the point slope formula. Need to, if you want to get out that page, I believe it was page 9 in your packet. 7. Okay. We're dealing with the point slope formula here again. We've actually done problems like this one already. Here is the point slope formula. Now, we're given the slope, we're given a point, and we want to graph the line that it goes through, as well as write the equation. Here's our substitution, our slope, the y value, and the x value. Notice we got a double negative right there. Minus a negative. Okay. So we simplify this, we distribute the 2, and then they actually did a couple of steps in the same one. They got 2x plus 8, and then they took this 2 over to the other side, all in the same step. Simplifies, there's your equation of line. Now we graph it. The y-intercept is the point 0, 10, right up there. Okay, then we're going to, from that 0, 10, we can either go up to right 1 or down to left 1. And they've shown both, up to right 1 or down to left 1. And you would keep doing this until presumably you would cross the x-axis. Another one, this time we got a fractional slope. It's the only real difference here. We do the substitution. We distribute, and again, they kind of did 2 steps. They added 0 to both sides, which didn't change anything. How did we get that 10/3? Well, 2 times 5 is 10, because technically there's an over 1 on that 5. And here's the graph. The y-intercept is 3 1/3. 1, 2, 3, and about 1/3. The x-intercept in this case is 1, 2, 3, 4, 5. So the 0.50. Another one just the same. We're going to go on by that one. What do we got here? Did I do this problem in this class already? Okay, it's the other class I did this one already. Because you guys aren't exactly at the same place. Okay, the difference here is they didn't tell us the slope. So we've got to take these 2 points and find the slope using the slope formula. Then after we find the slope, then we're going to go back in with that slope in the point slope formula to get the equation of the line. Okay, so they went right to left, right to left. 1 minus -4, -2, minus -1. Simplified it and got a slope of -5, which means you could go down 5 right or up 5 left. Now, once we've got the slope, then we can take either one of these 2 points. Now, it really doesn't matter which one you choose. Choose the one that looks like it has the easiest numbers for you. In this case, they chose that point. Okay, so here's the y is 4, -4, minus -4, and over here minus -1, and the slope of -5. We're going to distribute that 5 and take this 4 over to the other side by adding its opposite. Simplify that, and here's our equation of the. Now, in this particular case, the graph goes off my scale. What could you do about that? Well, you could call each one of these if you wish. If then we would have 2, 4, 6, 8, 9. But then we would, here would be 1, 2, 3, 4. We'd have to follow through with that as we went, and ideally keep both scales the same. Once in a while, you'll see a problem where they'll have a different scale for the X and the Y values. You try to avoid that if at all possible, unless your data just demands. Okay, here we go. Let's graph that thing, and it would come on down here to 9. Or -9 rather. Write the answer in slope-intercept. This and the slope is undefined. What is that? Anyone remember what undefined slope means? I see 2 answers. One says vertical, one says horizontal. Which one is infinitely steep? That's how you remember vertical is undefined. Okay? So, what do we know about vertical lines? We know that we take whatever their X value is, and we don't care what the Y value is. The Y can be anything, but the X always stays the same. Well, if that's true, then right there it tells you where this line is. Like so. Question on this one? Here again, we got a 2-step problem. First, we got to find the slope. Then we got to find the point slope formula. We're going to skip over that one and keep on going, because we need to do parallel and perpendicular lines. Okay. Now, if they happen to be vertical and a horizontal, they're automatically perpendicular. But not all are that. I mean, you can have perpendicular lines at these 2 angles or these 2 angles. Doesn't have to be that. Okay. Same thing with parallel. They don't have to be like this or like that. They can be at any angle in space as long as they never touch. Okay, or coincide. So here's the rules of slope for parallel and perpendicular. What this sentence is saying is, if M1 happens to be the slope of a first equation, and M2 is the slope of the second line equation, if they're parallel, then the slopes are the same for those 2 equations. Okay, that's translating that into English. Now, what about perpendicular? If they are perpendicular lines, then the slopes are negative reciprocals of each other, opposite sign and flipped. Okay. I prefer, instead of the way they showed it, is to say if slope number 1 is X, is let's just pick a number 5. Then slope number 2, which is perpendicular, and that's kind of the perpendicular symbol, would be -1/5. Now, keep in mind that this 5 is technically 5/1. Okay? So opposite signs, reciprocals. And that's what you got to do for the slopes on perpendicular. Now, if we know that, then we can, if we're given an original equation, we can determine another line that's either parallel or perpendicular to it. And that's what we're about to do. Okay, well, this is just practice doing slopes. Here's the slope. If you want a parallel line to that, same slope. Perpendicular line, opposite sign, reciprocal. And here's another one. And a third one. Okay. In other words, these are all vertical lines in this case. Well, that parallel would also horizontal, perpendicular would be vertical. Better watch what I say. Okay, now give the equation of the line that passes through this point and is parallel to the line defined by this. Well, first thing we got to do is we got to put that in y = mx plus b form so we can see what the slope is. Okay, because if we want a parallel or perpendicular, we better know what the original slope was. So we're going to do that, and we come up with that. Now, after we do that, after we've got it in y = mx plus b form, we see that the slope is 3 in this case. They are asking for a parallel slope and a line through that point. Okay? Well, here's our data, our slope and our point. So we can use the point slope formula. We do our substitutions. We're going to distribute here. And we're going to take this -2 over to the other side and ultimately combine those two. Whoops, too fast. This equation is parallel to that equation, okay? And this one also goes through that point. If we were to graph those, just to prove a point, this equation, here's 4, and we would go up 1, 2, 3 over 1, 1, 2, 3 over 1, down 1, 2, 3 over 1, and this line would go about like so. Okay, this line would start at 5. Let's see, that was 3, or that was 4. So up here is 5, and it would go up 3 and over 1, and up 3 and over 1, and up 3 and over 1, and down 3, 3 and over 1, and down 3 and over 1, and it would in fact be parallel to that one, and it would also go through the point -1, -1, 2. Okay. Okay, this one, they give us this. First thing we got to do, put it in point slope form. Well, that would be 3y = -x plus 6. Divide everything by 3. And we get y = -1/3 x plus 2. therefore, the y-intercept is the 0, 2, and the slope of our first equation is -1/3. Okay. Now, this is asking us to do it parallel. Okay, so my slope 2 is going to be +3/1.
Isn't it asking for parallel, not perpendicular?
Oh, yes, it did say parallel, thank you. I'm thinking ahead. In a moment, I'm going to work this same problem for perpendicular. Okay, so my slope remains the same. Now I've got to use the point slope formula with this point. So y minus 2 equals -1/3 times x minus -3. Is that to plus positive? So y minus 2 equals -1/3 x minus 1. Take the 2 over, +2 plus 2. Y equals -1/3 x plus 1. And there's our equation. Now, let's do the same thing with only use perpendicular. Okay, this one is a parallel slope. So I'm going to show you the parallel symbol there. Now, this far down, it's the same. Okay, so I've got y equals, now I've got to use a perpendicular slope. So perpendicular M2, or let's call this M3, third slope, is going to be +3/1. So this time, when we put this information into the point slope formula, we're going to have y minus 2 equals 3 times x minus -3. Change that. So we have y minus 2 equals 3x plus 9. We take this 2 over, +2 plus 2. Y equals 3x plus 11. That is our perpendicular line. Let's see if that's correct. Graph paper. Over here, I got this equation. Okay, well, actually, I've got 3 equations to graph. The original one, right here, there's about 2, the 0.02. Now I'm going to go down 1, right 3, down 1, right 3, down 1, right 3. And this line is going to go at about that angle. Okay. Now let's do this one. Okay, this is my parallel line. This time, my y-intercept is 1. 0, 1. And this time, once again, I'm going to go down 1, over 1, 2, 3, down 1, 1, 2, 3, up 1, 1, 2, 3. And this one is going to be parallel to the first, just like that. Now let's consider this third one. +11. 1, 2, 3, 4, 5, 5, 6, 8, 9, 10, 11. Okay. And slope is going to be 3/1. So if it's 3/1, it's also -3/-1, right? Which is the direction I'm going to want to go. Down 1, 2, 3, left 1. 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 And this one is indeed at a right angle to both of those. Okay. Or in other words, it's perpendicular to them. Questions on this one before I start erasing? This is the whole package. Okay. On my test, on the final, they will ask you problems similar to this one. I guarantee it. Or as a fellow who used to be called the Cajun cook at a cooking show, food it was wonderful. And he used to say, I guarantee it'll be there. Okay. They could give you parallel. They could give you perpendicular. You've got to know how to deal with it either way. Okay. And keep in mind, anytime it says write an equation of the line, what formula are you going to use? Well, you're always going to use this point slope formula. Here, they're just going to have you do it perpendicular. What are our steps going to be? Let's just kind of enumerate, think ahead. What is our strategy? Okay. This is not in y = mx + b format. So the first thing we need to know is what is the slope. So put it in y = mx + b format. Second thing we're going to do, since it says perpendicular, we're going to find the negative reciprocal of the slope of this. Then we're going to take that slope and this point with the point slope equation. Okay, it's just a repeatable process. So here we go. First thing we do, y = mx + b. The slope of this equation is -5/2. We want the perpendicular slope, so it becomes +2/5. Okay. So we've now covered my first two steps I listed. What was my third step? Take this perpendicular slope and use the point slope formula with that value to get the equation. Okay, so here's our perpendicular slope. Here's our point. We're going to put it into the equation. We're going to solve it. And in this case, here's our answer. Now, where did that come from? Anyone? Does that bother anybody? Let me show you where they got that. Just in case you're not certain. See this 8 right here? They took it in this step over to here. But they can't just add this 8, which is technically over 1, and that -12/5. They have to convert this 8 into fifths by multiplying it by 5/5. And when they do that, this becomes 40/5. Now, -12/5 and +40/5 28. That's where that came from. So if you've got a fraction on either side, because here, what they didn't show here either was that you had 12 fifths. They did show it down here, or minus 12 fifths, I should say. So anytime you've got a fraction on either of these sides, you're going to have to play the common denominator game before you can add those values together. Okay? Questions on this before I start erasing? Well, here's another one. The only difference is this time we don't have to convert to y equal mx plus b format. Okay. I'm going to go on through this one and we're going to deal with this. A wording problem. Speeding ticket, by the way, kind of. A speeding ticket is $2, $5 for every mile an hour over the speed limit. Okay. Two or 3 years ago, I got a speeding ticket on 21st Street. I was doing 47 and a 40. Now, if I'd been doing 45 or slower, he would have let me go. And usually, if I'd been doing 49 or slower, he would have let me go. But they were being particular that day. Okay. And so anyway, he gave me the ticket. Never mind the fact that my GPS said the fastest speed I've driven was 45. He didn't care. I think his radar gun got somebody else. But anyway, nobody's guilty, right? Everybody's got an excuse. The fees that I was charged were 130 plus 5 in my ticket. But we'll just go ahead and do this one, and then we'll figure out mine. So anyway, in this case, it says what? Write a model for the speed, okay. The cost of the ticket equals in this case, $5 times the number of miles an hour you drive over plus 100 up front. That 100 up front is kind of like you call the plumber and he gives you a $75 trip charge before he even starts. It's kind of the same thing. Okay. Now, this is a model or a linear function to model. It's just how you do it. Now, I didn't like their choice of variables, so I put it in this manner. Okay. I could have called this C of X, the cost based on the miles per hour over. Okay. Now, what this is saying is what if he was going, because I used a C here, what if he was going 15 over? Whatever the speed limit is, he was going 15 over. So you simply say the cost of his ticket is $5 times 15 plus 100, or in this case, 5 times 15 is 65. So the cost of his ticket was $165. Okay. In my case, that was 130, as I said. And the $5 was the same. And I was doing 7 over. Okay. So the cost of doing 7 miles over was $5 times 7 miles per hour plus 130 court costs, they call them. Okay, so 5 times 7 is 35 plus 130. So in my case, that cost me $165 for 7 miles an hour over the speed limit. I was not a happy camper. And still to this day, you could probably hear the resentment in my voice about it. Well, anyway, I won't go any farther than that. Not to mention that it messed with my insurance. Okay, questions before I go on? Okay, this is just doing substitute values of X into an equation. We're gonna skip over, okay? Here, they're using function notation, this, okay? And we're not gonna deal with that. These are problems. These are problems right here. This is a problem right here that's similar to those you might see on my test or the final, okay? We've done problems similar to those, okay? How do you write an equation perpendicular? Well, you take the original equation slope, opposite sign, reciprocal, and then do the new slope based on whatever point they want to go through. Okay. This is just another model, if you please. The cost to produce something in a factory. M is the variable cost per item. So you have how much per item times how many items plus the fixed cost. The cost of the machinery, the cost of the lubricants, the cost of whatever. Okay. You go to the car shop, they typically add an extra 15% on the end for what they call shop fees. Rags to clean stuff, lubricants, whatever. And that doesn't even count the oil they put in your engine. Okay, price per item times number of items, okay. What is profit? How much it costs to make it, right here. How much you sell it for. How much you sell it for minus how much it costs you to make it or get it if you're a retail shop. Those are just kind of commonplace sorts of things. Okay, let's look at this. You got this page in your packet. Turn to it, please. Have I gone past class? No. I haven't stopped and think about that a moment. Hey, everybody find it? Has a bunch of graphs like this on it. Page what? 29. Okay. Now, this page is something that you would probably be best off memorizing. Okay. Now, this is a page of generalities. This is a page of basic shapes. Okay. You know, when you're in probably second, third, fourth grade, your teacher wanted you to memorize, well, this is a triangle, that's a square, this is a angle, this is a whatever, okay? This is a grown-up version of that. Except now what we're saying is if you have a y equals mx plus b equation, this is the simplest of all y equal mx plus b equations. If you want to write y equal mx plus b over here, you could. Now, this one has a slope of 1 and a y-intercept of 0, 0. Because there's no b shown. Okay? And it's just up 1 over 1, up 1 over 1, down 1 left, 1 down, 1 left, 1. Okay? Single power on each term. It is just a simple line. Okay? And depending on modifiers, it could go at whatever angle. Okay? Now we move to the set of parabolas or quadratics, if you please. Of course, these, the standard form is ax squared plus bx plus c. Okay, y equals. Over here, like I said, 1 equal mx b. Now, in this case, this one is the simplest one. It has no modifiers. Okay, all of this stuff is modifiers. They shift it left, right, up, down, rotate it, depending on what the modifiers are. Well, that's where we're headed. Okay, but this is the most simple one. The parabola or c out here is 0. The c in this equation is also the y-intercept, just like the b was over here, the number. Okay, that didn't have any variables. And this, in this case, it goes up symmetrically. Okay, the two arms of a parabola are always symmetric to each other. Okay. Let's move over here to square root of x. Well, this is what it is. Square root of x. Why does it not have more? Well, technically, it kind of could, but it would be imaginary. Yeah. Because to do that, you would have to have negative square root values. Okay, so negative values will give you that. These are all positive values here. You also couldn't have that in this case, because x has to be bigger than 0 in this case. Okay, this is another name for that. If we have numbers added or subtracted under the radical, that's going to shift this thing left or right, opposite of the sign. If we have numbers out here by itself, it's going to shift the y-intercept up or down. Okay, it'll move it up or down. So those are what some of its modifiers. But this is a characteristic shape for a square root of x, which is the half power compared to the square power compared to the 1 power. Cube power, okay, typically starts down and goes up. If this is a minus in front, then it starts up and goes down. Okay, now, and these behave in that similar type of a manner. It flips them how the direction they go. Now, in this particular case, once again, plus 0 out here puts the y-intercept at 0. And this is just the generic form. You could have plus some x squares, plus some x's, plus some numbers out here as modifiers. But you need to know this general shape. What if you had x to the 5th? Well, Notice it started low, ended high, started low, ended high. 3, 4, 5 points on the x-axis, which we call roots or solutions. Okay? And so on. This one, if we moved it down, then we would have 2 solutions. In this particular case, there are certain circumstances where you can have fewer than the power number of solutions. And we'll talk about those as we get into this. Here, CubeRt of. CubeRt of is kind of the same shape, except it's actually the reciprocal. Okay. Let's look at this one. 1 over x. This is one you need to be aware of. Typically, when you have a variable in the denominator, you're going to have something like this, or it could be like this, depending on the problem. Absolute value will always be a v. Okay. Any of these equations, if you have a number out on the end of it by itself, that number will be a y-intercept. Okay. If there's no numbers by itself shown out there, then the y-intercept is 0. So I wanted you to be aware of these things. And now it is time to go. Wait a minute. Yeah. What? Wait a minute. No, we started at 5, so I need to go to there. I almost let you go too early again. Shame on me. Okay, look at these. Vertical and horizontal translations. What does translation mean? A movement. Okay. Let's see what happens here. In this case, this equation right here, this is kind of like a parabola, but not quite. Okay. In this case, this equation hit the x-axis in those 2 places. And because of this 1/5, it kind of spread out wider than we saw on our parabola a little earlier. Now, look what this adding this 5 onto the equation did. It took this y-intercept and moved it up 2, 4, 5 times. 5 places, I should say. Okay. Likewise over here, this one moved it down 3. So the number on the end, which also corresponds with the y-intercept, shifts it up or down. Okay. And that's called a vertical translation. I'm going to give you a moment to read that. Whatever kind of a formula, whether it's an x squared, whether it's x cubed, whether it's an x to the 4th, if there's a number out on the end of it, positive or negative, it'll shift it up or shift it down. Say again.
Picture. Go back.
Just ask to get the heck out of the way.
Go back.
Oh, one more? Oh, yeah, there we go. Got it? Okay. Now, they like to have you plot points. I hate plotting points. It's too much work. They make what they call an XY table. Here's another example of one. Okay. This is an XY table for the equation y equals x squared. If you remember on that sheet you've got in front of you, there is a graph that shows you what y equals x squared looks like. Vertex of that parabola is at the origin. and it goes symmetrically on each side. First point on each side is 1, 1, and negative 1. Okay? And I happen to somewhat have y equal x squared drawn here. Okay? Now, like I said, these are called the independent variables. These are called the dependent variables. You can pick the x values to be any number you want them to be. But if you're smart, you're going to pick them with numbers that are kind of compatible with the ones in the equation. So you don't have some weird fractions. Okay? Well, they chose 0. That's always a good one. Okay, what is it when x is 0? It's the y-intercept. You let x be 0, you get an answer of 3. Well, if we graph that, right here is the answer, 1, 2, 3. There's that first point. Then, they chose arbitrarily, let x be 1. 1 squared is 1 plus 3 is 4. So that gave them the point 1, 4. Excuse me, over 1, up 4. And the next one will be here. Notice how I went up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. This has the same format as the original, except it's just all moved up 3 places. Okay? And that's what that plus 3 does. Now, you can do this work if you like doing that. I don't. I'd rather use my knowledge of transformations that I know what y equal x squared looks like. And then I'm just going to shift it up 3 places and graph it and done. Work smarter, not harder for Carter. Okay. Now, do you understand what I'm talking about? Is there anything I've said on this example so far that might confuse you? Okay. But all of these, whether it's an x squared equation or a cube equation or a whatever, they fall into this pattern with these transformations. Okay. Okay, now, next one. Here's a radical. What's the basic look like? Well, here's an XY table for that equation. If you let x equal 0, it's the point 0, 0. 1, 1. 2 square root of 2, which is 1.414. 1.414, not quite half. If it's 4, then it's 2. Okay, and so 1, 2, 3, 4, up 2. And so on. So this is that basic equation. Now, what's this one going to do different? When it's under the cap or within a parentheses with the variable. If it's inside a parentheses with the variable, under the cap of this, inside an absolute value, symbols, then this is going to shift it left or right, opposite of sign. That might be a good sentence to write down. When a modifier is under the cap, inside the absolute values, or inside a parentheses with the variable, then it's going to shift it left or right, opposite of sign. So what are we going to expect this thing to look like? We can do this and graph it. But again, I don't like doing this. I'm lazy. I like to work easier. Or as the late great Tina Turner said in her movie Rolling River, we can do it easy or we can do it rough. And I prefer easy. Well, just in rough numbers, since that is plus 3, then I'm going to go negative 3. 1, 2, 3. This point goes to there. This point, 1, 2, 3, goes to there. This point, 1, 2, 3, goes to there. In turn, here, here, this thing is now gonna look like that. It's actually kind of flattened out a little more in the distance. So let's see how it compares with them actually doing it. There's the set of XY values. Okay. How did they get these? If they put -3 in there, -3 plus 3 is 0. Square root of 0 is 0. In this case, if they put -2 in there, then that gives you 1. Square root of 1 is 1. If they put -1 in there, then you get 2 square root of 2, which is 1.414 that we talked about, and the rest of them. Now, do you want to do that, or do you want to just do this and be done? I mean, your choice. Okay, makes this seem a little more attractive, doesn't it?
And since you don't really like the,
I don't like doing that arithmetic.
So does that mean that that's not gonna be on your test? Or that?
Depends on what the question is. If the question demands that you fill in the points, then you got to do it. But if it doesn't say, if it just said graph the equation, you could do it this way, or you could just do it by transformation.
And if we, let's say that's something doing that, even though it's not asking for it, or we end up getting, that wrong and that right, would you just count off like 2 points if you're close? Or if we got one,
Might only count off one, depending on, it depends on what you did over here, how bad it was. Okay, to answer the question you asked. Does everyone understand what we're talking about? Okay. Well, anyway, there's theirs. Oh, pretty close. This time. Okay, now, we wanted you to recognize basic functions. We want you to apply vertical and horizontal translations. How do you tell the difference? If it's external, it's up or down. If it's internal, it's left or right opposite a sign. Okay? Now we're going to talk about horizontal, vertical and horizontal shrinking and stretching. What am I talking about there? Let's start with y equal x squared. That one would be considered horizontally shrunk or vertically stretched. Do you understand that? And it depends on which way you come from in some notation that we'll talk about. Okay. What about this one? Well, that one is horizontally stretched and doesn't go up vertically as quickly. Okay. Now, there are certain characteristics. If this is y equals x squared, this one could be y equals 3x squared, meaning it's going up instead of 1, 1, it's going up 3, 1 and 3, 1. Well, it won't be uniform, but to that first point. Okay, here, this might be y equals 1/2 x squared. So it goes up half as fast as this one. Do you see what I'm talking about on this? If we just simply have this equation, y equal x squared, if we multiply it by 3, it's going to go up a lot steeper. Just like if I had y equals x, and I had y equals 3x, This line would go up as steep as that one. It's the same kind of a relationship, okay? If I had y equals a half x, then it's only going to go up half as fast as this one. Now, what do we call this? Shrinking and stretching. Well, let's go into that a little bit in some more specific, because I've used very broad general examples here. Here's just a line. There's just a horizontal line. This means y equals x, right? This means y equals mx plus b. When you see f of x, the word function, the difference in function and equation, you're going to have the function notation. F of x, g of x, q of x, h of x, those are all different names for y for some given equation. Okay? This y equals, g equals, q equals, naming it that way just as easily. Now, again, this is repetition of what we did with the chart earlier. Here you have the square function and the cube function. The square root function and the cube root function. Absolute value function. And reciprocal function or inverse function. Okay, now apply vertical and horizontal translations and shifts. We've already done vertical and horizontal. If the c is external to the variable, that c tells you to go up or down with whatever sign it's got. Okay. Here it's just going to tell you if c is negative, it'll go down. Okay, that's a vertical shift. Horizontal shift is when the number is interior with the x. Okay? Whether it's under a radical, inside an absolute value, inside a parentheses with the x, then it's going to shift it, in this case, however many to the right. In this case, how many to the left? Because it's always opposite of sign. This business is tied in with our discussion of circle formulas where you always had that minus in the middle and some other things that always had the minus, like the distance and so on. Okay, now, modifiers. What's this one going to do? It's going to go up like that, but it's going to be shifted 2 places to the up. Shifted up 2 places. Okay, here's some points. If you plotted them, okay, this time, so here's the basic points to go with chosen x's. Here's if you put a 2 on the outside. Every one of these are just 2 more than whatever that was. And remember, we got to use that because we took 1.414 plus 2. Over here, again, we're putting it on the inside, so it's a little different. 0 doesn't make much difference. It just leaves it square root of 2. If you make it 1 here, 1 plus 2 is 3, square root of 3, 1.732. Here, 2 plus 2 is 4, square root of 4 is 2, and so on. Now, what about the graphs of those? Here, we're going to go to those graphs. We already know what the basic graph is on this one, hopefully. The basic graph on this one is going to start here, pass through 1, 1, and go on up like that, right? This is the y equals square root of x graph. Now, what about this one? Shifts it up to. Here's my y equals square root of x graph. They finally did it for me. Of that one. It's going to shift everything 2 points to the left. This point goes 1, 2, compared to this, it's going to go over 1, 2. 1, 2. 1, 2. Okay, and I actually gave you these examples earlier. So again, that's your left and right transformations. Same thing happens with parabolas. There's the set of values if you do them, the arithmetic. But here's the y equal x squared, and here we just moved it down one. Notice here I go over 1, up 1, over 1, up 1, or up 1, over 1, up 1, over 1. It's the same ratio of growth, isn't it? Except it's just down 2 places. This one, on the other hand, we're going to take this one, we're going to shift it 1, 2 places, opposite sign to the right. Like so. Now, what if you throw both things in there? You will have some of these on both my test and on the final. For example, I might give you this problem right here, and you have to tell me what transformations will take place. If I gave you this problem and said, what transformations take place? You always start from the inside and work out. Okay? On transformations, always start from the inside and work out. Inside being where X is. So this, I'm going to shift 1 place to the left and down 4. I'm going to take the basic x squared shape. I'm going to slide it 1 to the left and 4 down, is what that's saying. So we're going 1 left, 4 down, and here's the comparison of the two. One ready. What about this one? Absolute value. We're going to have a V because of the positive and negative. You know, when you take absolute values off, you get the plus minus. That's why we've got, in this case, the V shape. So just the basic thing is a V starting here, going through 1, 1 up this way, through negative 1, 1, going up that way. So this is going to take us 2 to the right, opposite of sign, and 3 up. Whoops, too fast. Too slow. There you go. Okay. Tell me what you do on that one. Right, no, write it down. Write it down. And then try to graph both the square root of X function and the modified one. Okay, there's the basic. So, step by step, first thing we're going to do is we're going to shift 2 places or spaces to the left, opposite of sign. So this one's going to come over here. This one's going to come here. This one's going to come here. And this thing's going to go up like this, just for that part of it. So what is this? This is f of x equals square root of x plus 2, is what the red stands for. Now, the final step, minus 5. We're going to take this down 1, 2, 3, 4, 5 spots. We're going to take this down 1. Let's see. Here's 1, 2, 3, 4, 5 spots. This one, 1, 2, 3, 4, 5 spots. And this thing is going to go like that. Okay. This is your final answer on this case. F of x or y equals square root of x plus 2 minus 5.
Get the shifts, but how do you graph this?
Well,
Or if you like square rooting, taking that to the power of 2.
okay, do you agree that this is the standard form according to that sheet I gave you? For this equation? What I did here was for this one, just that part of it by itself. I shifted everything on this one 2 places to the left. Okay? To get to this one then, I took that one and then I shifted everything down 5 from where they were. Now, if you wanted to, you could do an XY table for f of x equals square root of x plus 2 minus 5. Okay, here if you let x equal 0, then you got square root of 0 plus 2 minus 5, or square root of 2 minus 5, or 1.414 minus 5, which is whatever that is. Okay. It'd be 3.6 roughly. Okay. 0, 3.6. Then I could let x be 1. I'd go through this same process. 1 plus 2 plus 5, square root of 3 plus 5. No, this is minus 5. Minus 5, 1.7, just to round it off. Minus 5 is approximately 3.3. So I let x equal 1, and here, whoops, this is negative 3.3. And negative here also. So it would be about right here. Okay, if I let x equal be 2, what did I say here? Approximately negative 3.3. If I let x equal 2, then I would have square root of 2 plus 2 minus 5, which is square root of 4 minus 5 is 2 minus 5, which is -3. So if x is 2, then I'm right here. And I could keep on doing that, and that would plot this graph. But I sure as heck don't want to do that when I can do it by transformations. Because you saw how much faster it is. I've taken more time doing those 3 points than I did the whole thing before. So it's really beneficial to you to learn those. Plus, you're going to be tested to see if you know what these transformations do. You will be tested on that. Promise. Okay. Questions? Any more questions about this? We're probably at a good stopping point tonight. We could go on. This is where we'll take up. Actually, we've done a little bit of Monday's Alex. Not a lot, but a little.